Because it's time for math. Thank you, Bayside Tigers, for introducing our next math lesson. Simplifying rational expressions. So our learning goals, we are going to hone thy factoring skills. We are then going to simplify rational expressions and learn something called stating restrictions. So we're going to start off with a little warm-up definitions. What is another word for rational? Well, another word for rational, that's just a fancy math term for fraction. And you don't really have to copy down this first slide. You can just listen, pay attention. What can you never divide by? So there's definitely a number that your calculator will always spit back an error to you. Does anybody know what that number is? It does rhyme with the word hero, starts with a Z. Hopefully that's a good enough hint for you. You can never divide by 0. If you divide by 0, it will give you an error. It's impossible. So what you can never divide by is 0. Now, variables in general can be anything except in rational expressions, fractions, where they can be anything but what will make the denominator, which is the bottom of the fraction, 0, at any point in the simplification process. So we're going to borrow that idea for doing something called stating the restrictions. Our first example, we are going to state the restriction. Restriction just means what can't you do, or what are you restricted from doing. I can never divide by 0, which means if I have a variable in the denominator, there's going to be at least one instance, possibly more, where there's going to be certain values that are going to make it impossible to divide by. Looking at A, our denominator, 3y, which basically just means 3 times y. And if we want to state the restrictions, we want to state to the reader, what can't y be? In other words, what will make the bottom 0? 3 times some number is 0, and we never want it to be that because it's not possible. Hopefully you're thinking 3 times 0 is 0, therefore y can't be 0. How do you write that mathematically? Well, y, and if equal to is like this, can equals, just has a line through it. So y cannot equal 0. And that right there just means can't equal, or can't be. B. Again, all we care about is the denominator. Don't even bother looking at the numerator. Now we have two variables. Something squared times another variable can't be 0. Well, if we're multiplying, that means either x could be 0 or z could be 0. And we don't want them to be that, so x cannot equal 0 and z cannot equal 0. C, 3x minus 9. 3 times some number minus 9 can't be 0. Some of you could probably sit there and stare at it long enough and figure out what that number is. And if that's you, maybe by now you figured out 3, because 3 times 3 is 9, 9 minus 9 is 0. But what if you can't figure that out? Well, most of you, I'd hope, are probably pretty good at solving equations. So basically, you want to solve this equation. 3x minus 9, and we won't know that we don't want it to be 0. So I'm going to write can equal 0. And you treat that just like an equal sign. So if we want to solve that, bring that negative 9 over, it becomes positive 9. 3x can equal 9. Divide both sides by 3. Lo and behold, x can equal 3. If you're someone that knew that right away, you can just write x can equal 3. That's like a 1-mark question. Don't feel bad if that's not you, though. You do as many steps as is necessary for you, and if you show all that work, that's also good. Remember, too, when it comes to quick tangent here, if it's a 1-mark question, 2-mark question, however many marks it is, the more work that you show, that you demonstrate to me what you're doing, the more part marks I can potentially give you if you make an error. So in this case, if someone just writes x can equal, I don't know, can equal 4, I have no way of knowing how they got 4. Or let's say 6. 6 is a better example. Let's say they said x can equal 6. I have no way of knowing unless I guess how they got 6. But if I see someone do the steps that I just did, and instead of dividing by 3, they subtracted 3, and 9 minus 3 is 6, I can be like, okay, well, that person just made a really silly error. They know more or less what they're doing. So in one case, someone writes x can equal 6. It's wrong. You get 0. Somebody else shows me all this work, just makes one silly little error. If this is a 1-mark question, I can give them a half out of 1 because they've shown me something. And that goes for any question. I'm a big proponent for math. The final answer is only worth a smidge, a little bit. The final answer, it means something, but overall, the process is what matters the most. Mathematics, the process matters the most. And so I'm always going to mark process and not just the final answer. That was just a quick tangent. Next one. Just for the sake of everybody else, even if you know what the answer is right away, that's great. I'm going to show all the steps. We don't want the bottom to be 0. So we're going to set that up, bring that over. Becomes positive 1, divide both sides by 2. Y can't equal 1/2. Now, if you're asking, can I write 0.5? I'm going to hesitantly say yes, but the expectation, especially when you get to advanced functions, which I'm assuming you're in this course because you want to get to 12 advanced functions, otherwise why would you take this? But assuming you want to get to grade 12 advanced functions, we only want to use fractions. Fractions are better, especially when it comes to non-terminating decimals. Now, 1/2 is 0.5. That's a nice decimal, fine. But really, you should try to increase your comfort level with fractions during the course of this course, preparing yourself for advanced functions in grade 12, assuming you're taking that. EF, and that should not say C. That should say G. Apparently, I don't know my alphabet. G. And we want to state the restrictions. These are progressively getting a little bit more difficult. E. Now, some of you might be able to stare at that long enough to figure it out. It's kind of a tough one. And there might be more than one answer. So we want to know what will make the denominator, the bottom, 0. So that way we can write to someone, don't let it equal that. Well, that's a quadratic, and we just learned how to factor quadratics. And if you're wondering why would I want to factor that, well, if you remember from grade 10, when you factor a quadratic and get it to factored form, that actually lets you find the zeros. What makes it 0, which is what we don't want it to be. So I'm going to factor this. How you factor, it's completely up to you. So I'm just going to stick to this is a simple trinomial, and we want two numbers to multiply to this and add to this. So x plus 9, x plus 1, and We don't want that to be 0. So my zeros are x can equal -9 and x can equal -1. You can list them like that, or if you want to save yourself a little bit of writing, you could just write x can equal -9, comma, -1. Same idea for f. We're going to have to factor that. This is not a difference of squares. This is not a trinomial. We're going to check for a common factor, which in this case is 3x, which leaves us with x minus 1. And I'm going to go through the factoring fairly quickly through this and the rest of this unit because we did a review lesson on factoring, and it's my hope that you're going to catch yourself up to speed. With that being said, if you're not able to get the factoring this quickly, or you need to do the box method to kind of organize your thoughts, you can just pause the video and do as much work as you need to off to the side. So for this first one, x can equal 0 and it can equal 1. G looks a little bit different. We got x minus y. You could still set it up the same way. I don't want that to be 0. Bring that over. It becomes positive y. You're done. X can equal y. Now that works both going left to right and right to left. So if you were thinking, well, maybe I should also write y can equal x. You could, and you're not wrong. It's just an extra line. X can equal y, which implies y can equal x. Moving on to simplifying rationals. Factor whenever possible first. Reduce any coefficients in the fractions whenever possible. Cancel out any repeating factors in the numerator and denominators. This is the big step right here. This is the one, this is the money step. And simplify and state any restrictions. Do not forget this. This is always going to be worth an additional mark or two. And even if the question doesn't say state restrictions, if you are doing anything with variables and fractions, it is just implied that you will always state restrictions. Always tell the reader what the variable can't be. So we are going to simplify and state any restrictions. So first thing you want to do is always common factor. So we can't factor anything out of the denominator, but the numerator we definitely can. And we can common factor out a 2, which leaves us with 2x plus 3 all over 2. Now that we have it like that and we're multiplying, right, 2 times that stuff in brackets, we can cancel out. 2 divided by 2 is 1. In other words, we can cancel out. That 2 cancels out that 2, and we are just left with 2x plus 3. Now, I don't have anything in the denominator that's a variable, so this one actually has no restrictions. It's just a 2. B, let's do the same thing. So let's factor the top, which would be a common factor, which would be 2x, and that would leave you with 3x squared plus 1 all over 2x. 2x divided by 2x, that's 1, or in other words, they cancel, and you're just left with 3x squared plus 1. Simplified. Now this one, we have a variable in the denominator, and again, if it's there at any point, so even though we've canceled it out and it's gone now, if at some point in the question it was there, you have to state the restriction. So 2 times something can't be 0. Hopefully you're thinking That's x can't be 0. So you can see why, now as we slowly get more complicated, why factoring is going to be a big part of this unit. Now, there is a common mistake that is made every single time. Every time you do this in the picture, so you can see they've canceled out x squared with x squared. Just to drive the point home, we're going to say a kitten dies. You don't want to be a kitten killer, do you? I know Norfolk has a stray cat problem, but we don't want to kill any cute little kittens. Look at that little guy. So remember, don't do what is done in the picture. So I'm going to give you another example here of what not to do based off of what we did. So let's go back to this. So we're going to say don't do. This would be bad. This would. This would kill a cat. We don't want that. So let's go back to B. Definitely don't do that. As you can see, that's not even the right answer. That would just leave you with 6x cubed, and we know the answer is supposed to be 3x squared plus 1. You are always factoring, or you can only cancel out when you multiply. When you add and subtract, you cannot cancel things out. And maybe I'll give you a numerical example for why that is. So let's say you had, I don't know, 2 plus 3 over 2 plus 5, let's just say. So if you think it's okay right now to cancel out the 2's, because there's one on the top and on the bottom, that would leave you with 3/5. Most of you seeing that with the numbers hopefully know or aren't thinking that actually is the right answer, because 2 plus 3 is 5, and 2 plus 5 is 7, and 3/5 does not equal 5/7. So there's a numerical example of why you don't ever do any canceling if you have terms separated by a plus or a minus. However, as soon as we start multiplying, because we're factoring and we have stuff in brackets, we can start canceling stuff out. So if instead we had this, 2 and 3 and 2 and 5 with multiplying, you could cancel out the 2's and you'd be left with 3/5. And how could we test if that's correct? Well, if we did the multiplying, we'd be left with 6/10, which if you divide both of those by 2, gives you 3/5. Those things are good. Kittens are happy. So remember, and again, I'm going to keep saying this because somebody's going to make this mistake. I hope they don't. You can't do what's in that picture. What I've just shown you, again, you can't do. Every time you do, remember the poor kitten. And don't let friends kill kittens. Friends don't let friends kill kittens. Not in math class, anyway. So there's that kitten just reminding you. So you're not going to cancel out the 5's. If you look at C, you're not going to go right ahead and start canceling out the 10's. Same thing with D. We always have to factor first. You can't cancel, you can't reduce when you're adding and subtracting, only when you're multiplying. So what can you factor out of the top? Well, just a 5, which will leave you with x plus 2. And what can we factor out of the bottom? A 5, which would leave us with x minus 5. Sorry, 2x minus 5. Now we can start canceling. Those cancel, right? 5 divided by 5 is 1. And all we're left with is x plus 2 over 2x minus 5. And now we can cancel out the 2's and the x's, right? No! We don't want to kill any kittens. Can't cancel, we're adding and subtracting. That's it. Now we got to state our restrictions. Well, for our restrictions, 2x minus 5 can't be 0. Bring that over. 2x can't be 5. Divide both sides by 2. X can't be 5 over 2. Again, do you have to show all of that work? No, that's just for the people that would benefit from seeing it. D. 3x squared in the numerator on top, can't do anything with it. On the bottom, well, can we come and factor out? Well, we come and factor out a 3x, which will leave us with x squared plus 5x plus 6. And then you could factor again what's in brackets. That's a simple trinomial. Again, I'm going to cut right to the chase here, but when you go to do your seat work, your homework, and do your test solutions, you should show how you factored these somewhere in the margin or right beside it. Again, do as much work as you need to be able to factor these correctly. But what two numbers multiply to 6 and add to 5? 2 and 3, x plus 2, x plus 3. So here's an interesting one. And I like factoring, so I like this unit, and I like factoring, and I'm doing my best to keep as many kittens alive as possible. But here's what's interesting. Okay, so the 3's cancel. Now you kind of have to go back and remember your exponent rule. So when you divide, remember you subtract the exponents. So I have an x squared on top with an x on the bottom. 2 minus 1 is 1. Another way to think of that or to look at that is I have 2 on top and 1 on the bottom, which just leaves me with 1 on top. So all I'm left with is x over x plus 2, x plus 3. There's nothing else you can cancel. Remember, you can't just cross out those x's. Aside from the kittens, all joking aside, you have an x plus 2 and an x plus 3. They're separated by a plus or minus sign. You can't do that. Now our restrictions. Usually you go back up to the step where you started just before you started canceling stuff out. So I started canceling stuff out here. So we should revisit this site for the restrictions. So I'm just going to write R. So we have one restriction already from this. And actually, you can look at this step too for your restrictions because it gives everything. Just sometimes it's confusing to see stuff crossed out. So go up here, we see 3x. That definitely means x can't be 0. Now going down here, looking at this, x definitely can't be negative 2, and x definitely can't be negative 3 because that's what will make the bottom, the denominator, 0. Hopefully that's starting to make sense. And again, if not, please, please, please let me know. E and F, same thing. Simplify and stating restrictions. We got a little cat looking up at what you're about to do, hiding in the grass. Factor, factor, factor. Those are simple trinomials. Again, I'm going to cut right to the chase. You do as many factoring steps as you need to. X plus 5, x minus 1, and x minus 5 and x minus 1. Now that we're multiplying, we can start canceling stuff out. Anything divided by itself is 1. In other words, it's gone. And all we're left with is x plus 5, x minus 5. And no, if what you're thinking is you can cancel out those x's and 5's. No, 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 no. Separated by plus or minus cannot do it. Our restrictions, we'll go back up to this step. X cannot equal 5 from that, and 1 from that. F, factor, look for a common factor first. If I look at the numerator, 2, x squared plus 7x plus 10. And if I look at the denominator, I actually have nothing to common factor. That is not a simple trinomial. So you have 3 options. So I'm just going to rewrite those 3 options. Box, decomp, Sulio style. Up to you. So if you want, you can pause it right now, try to factor the bottom. Might be a good little little pop quiz for yourself if you remember how to factor, if you know how to factor yet. I'm going to go right to the answer. So depending what style you use, you should have got 2x plus 3 and x plus 2. Got to keep going with the top. Top now is just a simple trinomial. 5 and 2 multiplied to 10 add to 7, x plus 5, x plus 2, 2x plus 3, and x plus 2. Now we're ready to start canceling stuff out. So there's only 2 things to cancel. X plus 2, x plus 2. That leaves us with 2, x plus 5, 2, x plus 3. Can't cancel the 2's out. On the bottom, you have a plus sign, right? Now we're going to state our restrictions. We will go back up to the step where we started canceling. So I'm going to look here. X cannot equal. Now the first one's kind of easy. It can't equal -2. The next one, you can solve that how I have been so far, setting it equal to not 0, solving a simple equation. The other way to do this simply, I see a plus sign. I know it's going to be minus. And then it's always going to be this number on the right over the number on the left. So it's always going to be this number 3 over this number 2. So 3 over 2. And if you don't remember that, again, you just solve that simple equation. I'm going to keep saying this probably at least once more after this. When I'm factoring, I'm giving you the final answer. When you do this on a test, especially, you need to demonstrate to me that you know how to factor and not that somebody else that you know knows how to factor, or you don't know how to use a certain app on your phone to factor. You have to show me the actual steps you used or the number combinations or how you got it. You need to prove to me how you did this. So if this was a test question and I saw you answer it like I just did without showing me any of the work, I don't know that you actually did it. I know that you knew how to cancel stuff out, but I don't know that you knew how to factor. So please, please, please remember, I can't stress this enough, show me your factoring work. Or if it was a simple trinomial and you did it in your head, just make a little note. Like you could just write to me here, simple trinomial. And I know that, okay, I can buy that some of you for sure can go from this step to this step, no problem. But the bottom of the denominator is not a simple trinomial. I would need to see the box method done, I would need to see the decomp done, or I would need to see the Sulio style done. G and H. These are our last 2 examples. I know this lesson's a little bit longer. I've had some digressions. So by now, we know factor, okay? Now G is weird. G it's kind of, it looks the same, but it's really not the same. So if we were to rewrite this, let's just, So unfortunately, it skipped ahead, and with what I'm using to record these lessons, it doesn't let me go back. So that doesn't mean we're done. Well, we are done, but this little version. But what I'm going to do is we're going to leave off here. Your C work is 1.1 of the homework package. Like I've said before, do as many as necessary for your learning. There are a ton of questions. Practice makes perfect. Maybe start out doing every other one. If you think you get it or you got it, then just go to the next question. Skip 3 or 4 maybe. Again, you should only practice the ones that you find difficult or you don't know, because that's how you're going to get better. And don't forget this homework package. So there's no textbook work really for this entire first unit. It's just in that package. The questions in the textbook aren't that good. That's why we have this package. If I were you, I would download it onto your device, onto your computer, and then you could refer to it. You don't have to keep waiting for it to download every single time. And don't just view it in D2L, because D2L sometimes does some weird things when converting the Microsoft Word equations, the symbols, to a viewable format for you, and you might see some weird like upside down question mark type things. But so yeah, so I apologize for that. What I am going to say though for that last example is maybe try G and H, go back, rewind, try G and H on your own. And the solutions, so the solutions to G and H are in the paper copies of the notes. So I've referred to those in the orientation video, I believe, or I should have when I do end up talking to you guys, plus in the email, I think. So remember, if you go to content and then unit 1A rationals, it has the lessons in there, and the lessons might be a little bit different than how the video lessons are, just because the last time I taught this course, it was not during a quadmester. So you might have to do some like clicking and experimenting to see which one goes with which video lesson. But I think for the most part, they're in the order. But yeah, let's say do G and H as a you try, like first kind of homework questions before you get into that package. And then to see if you got them right, just go into the content, unit 1A rationals, lesson 2 simplify, and then scroll down to where it says G and H. And then you can check to see the answer's already filled in there, just won't be my voice obviously showing you. And then double check your solutions. And if you have any questions, please let me know. Now, I believe, I'm not 100% positive, but I believe the next lesson, the next video lesson I have for you was recorded in a previous year. I started making these videos a while back, doing it every now and again, just because some students liked having it, and with the goal of having like eventually some compendium of my courses. But now that we're in a quadmester and COVID, that's accelerated that process. But anyways, the moral of the story is, I think the next video, or at least, and some other subsequent videos, they're going to refer to like other timelines, different classes. So just ignore like my references to specific things and pay attention to the material. And some of the questions and stuff that we do might be a little bit different from like lesson to lesson, but for the most part, just pay attention to the general material that's involved and ignore any specific references. But that's enough of me rambling on. Good work, everyone, on your first day, and definitely see who's going to introduce our lesson or lessons tomorrow.